Next, coming for the op-amp parameters, that is the operational amplifier parameters. The first one is CMRR, that is the common mode rejection ratio. Here in this common mode rejection ratio, as I said, if both the inputs are same, having the same input, output will be 0. That means they will be get cancelled. Hence, we should have to avoid that one. For that purpose, this will be used common mode rejection ratio. This is the measure of an amplifier ability to reject the common mode signals. If both the inputs will be having same input, at that time it should have to reject the input. That is what the CMRR will be, common mode rejection ratio. Okay, here CMRR will be equal to AOL divided by ACM. Here the OL is nothing but the open loop gain, CM is the common mode gain. This is about the parameters of the operational amplifier. Next comes the slew rate. It is the maximum rate of change of the output voltage with respect to the step input voltage. Okay, however the voltage variations will be occurring at the output side with respect to the sample time. Okay, that's about the slew rate. Just like a step response will be there, that is about your slew rate of the operational amplifier. It will be depending upon the high frequency response of the amplifier. Okay, we can define the slew rate, that is slew rate will be equal to delta V max divided by delta T. Here the delta reference the change in voltage with respect to the change in time. Okay, that is about the slew rate. These two are the main important parameters of the operational amplifier. Some problems will be there, you can see that one. And coming to this inverting amplifier, as I said, derivations will be there. I will talk about the first one is inverting amplifier. Sometimes they will be asking about the gain, all those things. Here the input will be given at the negative terminal, the positive terminal will be grounded. Here one term will be there, that is the important concept, virtual ground concept. That is VA will be equal to VB. Here VA is the first one given at the negative terminal, VB is at the voltage at the positive terminal. By using the virtual ground concept, we can say that VA will be equal to VB. Suppose if VB is grounded, here VB is grounded, that's why VA will be also considered as 0 only. Okay, now we will see about the circuit diagrams. First input will be provided, Vi will be provided, input resistance will be there, feedback resistance will be there. You should see about the currents. This is about your input current II, and IF is the feedback current flowing in the feedback path of the operational amplifier. Now with respect to the derivations, here by using the current equations at node A, we should have to concentrate at node A. Okay, that is the input current will be equal to the feedback current, that is incoming current will be equal to outgoing current, that's why II will be equal to IF. Next II will be same as it is. Instead of IF, how will represent the current? I equal to V divided by R. R is nothing but the Ri. Okay, and that is current II. You can represent this current II. I equal to V divided by R. R is nothing but your Ri. Coming for the voltage, we should have to take the voltage difference between this point and this point. Okay, that is Vi minus Va I should have to consider. But by using the virtual ground concept, Va and Vb both are same. If Vb is grounded, that is 0, obviously Va also 0. Hence I can write II will be equal to Vi minus 0 divided by Ri. Similarly, with respect to the IF also, IF equal to 0 minus V0 divided by Rf. Okay, by substituting the equation and rearranging the terms, I can obtain V0 equal to minus Rf divided by Ri into Vi. If I want in terms of gain, Av equal to V0 divided by Vi, that is equal to minus Rf divided by Ri. This minus sign indicates the feedback given at the negative terminal of the operational amplifier. That is important, why we are getting the negative sign. Okay, for the point of examination, this is important. This is about the inverting terminal. Similarly for the non-inverting terminal also there. Just look at the diagram, same thing. Just concentrate about the currents here. Here the input will be given at the inverting terminal, sorry, non-inverting terminal. Here the input will be given, inverting terminal will be grounded. Okay, again the same concept by using the virtual ground concept. V1 equal to V2 equal to Vi equal to 0, sorry, Vi input will be given as Vi by using the virtual ground concept. The input current I1 will be equal to If. Okay, again by using the Ohm's law, I1 will be written as 0 minus V1 divided by R1. If will be written as V1 minus V0 divided by Rf. Again substituting and rearranging the terms, I can obtain the last one. V0 will be equal to Vi into 1 divided by Rf divided by R1. In terms of voltage gain, AV equal to 1 plus Rf divided by R1. Here the plus sign indicates the input is given for the non-inverting terminal. Okay, these are about the some of the introduction about this, how the voltage gain will be, what is the inverting and what is the non-inverting voltage gain, all those things.